they are just, that's not something we are good at, right? But in terms of reasoning, making connections, we are way better. Making connections, we are way better. For making these kind of connections, it takes the machine lots of time to ever come to this. But for us, yeah, reading this document for like half an hour, you make the connection. Okay, that's why you guys are here. We need you to translate English text into code. Machine couldn't do it. That's your job. That's your job. But basically say how we step by step do that translation. That is basically software engineering. All right? So hopefully some of you, so we'll come to our second example. Hopefully some of you have already looked at this example from previous chapter we didn't have time covered, right? But even if you haven't, okay, this is the point I would like to make. Even if you haven't looked at the case study, by looking at this use case diagram, what can you tell? All right, this is basically like what I said. Okay, somebody else already did the use case diagram, and now it hand over to us to do high-level design, right? First, we need to understand the use case diagram, right? How to understand? Easy. We just read it. What does this picture, this use case diagram tell you here?
A staff member can do more things than a borrower.
Oh yeah, that's definitely this user is doing more, participating in all use cases, and this guy, the borrower, only participating in one use case. That's true. What can you tell from this diagram? How should you read this diagram? You're making this diagram in your requirement. You better know how to interpret this diagram, right?
What specifically are you asking? Because
I'm just asking your interpretation of the diagram.
well, the staff member can do 5 different things with
Okay, that's one observation.
so
What else?
Your users are going to follow them. So.
Oh,
Go ahead.
you're
Go
fine.
ahead.
I was just gonna say that the borrower needs a staff member to interact with the system.
That's right. That's right. What else? When you look at this, the first thing you need to ask yourself is, what is the system? What is the system here? It's right here. This foundation information system. That's the system we're looking at. Basically, this box is that system. Okay? Then the second question is, who are the users? Come on. You are doing a system, right? You first better know what that system is for. Second, you better know who are using the system. The third one is actually how they are using the system. Very simple. What, who, and how. The same information I'm looking for your requirement document. Same thing. What, who, how. What is the system? Who are the users? How they are using the system? One functionality, second functionality, third functionality, all 5 functionality right here. That's it. This is how you read a use case diagram. Questions? This is it. This is how you actually take somebody else's use case diagram and decipher it. Go ahead.
So for our project, I mean, we have the 5 use cases of register, login, send a message to everyone, send a message, et cetera, et cetera. What about I mean, is it not a use case that the user would receive a message from other users?
Yes or no? Okay, you can make a use case if you like to. Nothing prevents you as a designer to design your system that way. Consider your system design that way. Or you can say, no, that's not a use case. That's part of a use case for send a message. Up to you. That's why it's a design. This is not a mathematic computation. Have an absolute 0 and 1 answer. This is your design or my design. We can debate. We can evaluate whether my design is better than your design with some criteria, but your design is perfect valid design. Okay? I cannot say that's the wrong design. This is not in algorithm. I want you to come up with a ON design. Then there's a yes or no answer, right? Is your algorithm delivering on the ON complexity or ON square complexity? If you're ON, you have met my requirement, you got 1. If you are ON square, you didn't meet my requirement, you got 0. In our case, in design, okay, if you covered all the functionality, perfectly valid design, whether it's good or not, debate. We have to come up with criteria to debate. It's more gray than 0 and 1. That's a very good question. So in design, so as long as you cover all the functionality, if you come to one single test case, one single use case, I say, this is a system. Okay, I'm going to look for your step-by-step, which basically cover all the functionality all to the end. If you miss, you still get a point deducted. See what I'm saying? I'm not just looking for this single diagram. I'm actually going to look into this and your step-by-step and say, have you covered step-by-step all the functionality you have in the system? Then you can have a use case, say, this is using ChatF. Okay, good. I'm going to actually say, you have to cover all the possibility, right? So you have login, all this information, then you have create user, login, send a message to a single person, send a message to other person. This is going to be long for you, the single use case description, maybe 5 pages, right? However, if you have created 5 use cases, you actually chop them each one into short one. They can actually combine with each other. Then you don't have to have so many such a long sequence, right? Because you can combine, right? So then we can clearly, your design may not be a good design in that case, but if you cover them all, I'm still going to give you a point. But cover them all that way, it's going to be difficult. You're going to realize that's not a good option pretty soon. But that's a very good question. We have many design can work. There can be good design or bad design according to a given criteria. However, if no criteria given, any design is possible, right? So, but hey, if you pursue one design, you better make sure your design cover everything. If your design not cover everything, it's incorrect. If you cover everything, then we can talk about whether it's more optimized or less optimized. That's a different discussion. In other class, for instance, in system, right? In system, then performance is actually, have you reached this performance level or not? If you haven't, you're wrong. If you reached, you're correct, right? Many design would not reach that level. It's the wrong design. But in our case, it's not the wrong design. It's a valid design. Go ahead.
So we have, basically these use cases are sort of overviews of areas that we're going to be getting into. Now, as far as taking each use case, they're going to encompass a number of classes.
Yeah.
Right? And then from those classes comes our sort of UML and state machine.
Right.
Or state design.
Yeah.
Okay.
So we'll talk about that. That'll be right now we're going to talk about right now. Okay. So here we have these use cases, right? So we, from previous somebody else, right? Then we can say, oh, this is one scenario. We are actually flashing out each use case to enumerate all the possibility in this use case. Okay? For this use case, the second different scenario, and one more possible scenario, and so essentially we look at all the use case, each use case we can say the scenario. Then we can use the same approach, like non-extraction, to say what are the candidate classes we have. You can see that same elevator, the MSG Foundation information system, we use the same approach of non-extraction to identify the candidate classes. Then we decide whether some information need to be kept or not. Then we actually start with something very simple, say, okay, guess what? I think long-running information in our system is only two things: mortgage or investment. For anybody who are in the mortgage investment business, which this is actually their fundamental information, right? Now let's see, okay, they are all assets. So this is actually a refinement, optimization. So now we can actually use a use case, and we'll try to make the use case. So in this case, they actually trying to update the use case diagram, which should just say your use case diagram may not be. So that's why you have your use case diagram can also be optimized, right? You can have single use case which cover everything, but it's very complex. Or you can have 4 use cases, which each by themselves are pretty simple. They cover all of them by combination, right? Now, once we have this, we basically say, okay, guess what? We really only have 2 classes in the system. And if all the nouns are either in 3 categories, they are a class, they are attribute of class, or they are information that not necessary in the passage. Just make the passage read better, but not necessary, okay? So that's why we have name of the class as an entity, and attribute attached to entities, okay? All your nouns are taken care of by this way. All right? You have your components in the system now. Then the second one, so now we are going to actually do what you are trying to say. Now we have all the use cases, we have classes. How do we assign functionality to those classes? Basically, how we add methods to each class. Okay? This is how we do it. We look at the dynamic system level behavior, right? This is essentially, okay, once we start a system, we are waiting there for command. If command come, we do something, we go back, right? Corresponding to the each use cases. All right? So now, what we're going to do is, so you can actually create an interface like this. Very simply, you can do this easily, right? Based on the event loop. Or if you're using Linux, you can even do this command line, right? Now you essentially, we come to, okay, man, we do need a min program, right? If there's no min program, then this thing really couldn't, just data, we need the min program which will actually have some functionality there we can do. Well, but the key thing here is how we map our use cases to these entities. What we do is called use case realization. This is the core. You actually use non-extraction to find all the holders of your information, either your data, or they will be the bearer of the actions, okay? But how do you assign your methods to these classes? An easy way is, okay, I'm going to realize my use cases by the classes we already identified. How do we do it? We look at verbs. Essentially, we look at the verbs in the original specification and trying to assign them to different classes. Okay? We assign them according to use cases. So how do we do it? We take one use case. This is one use case from a use case diagram. Okay? We actually describe the use case. Here is the class diagram. What is the class diagram? This is essentially what classes we have in our system. Okay, this is going to be the holder of our information. In terms of attributes, we already assigned, and also actions, action bear as well. So what we do here is we have the static holder bucket. Then we are going to take one scenario of the use case. This is take your use case step by step. Then actually replace and really go inside the system and assign functionality to the classes. Okay? Here is how we do it. So these are the classes we identified. We also identified use cases. For use cases, we also have step by step. Step by step can be further fleshed out into different scenarios. Okay? Then we assign functionality to each class. If a message go into a class, that's a functionality that class need to implement. Send the message to different class, that is functionality can be called from different class. This is how how we actually finish up our high-level design. The rest of the chapter basically repeat this many, many times. Remember, in our original passage of that description, we have two major types of information. Adjectives, we don't really need to worry about too much about that, those things. Mainly, we're looking for nouns and verbs. Nouns are not the information we need to keep somehow. Or it's not useful, we just don't need to keep the information. If it's useful, either it's going to be the name of a class or attributes. Verbs are going to be action assigned to each class. How do we assign actions? We take each use case, we flash out step by step. We flash out step by step. Okay? So if you use Google Map, if the Google Map instruction, if you say, oh, I want to go from my house to PSU. If the Google Map say, okay, go from your house to PSU, is that instruction useful for you? No, that is essentially your use case. Okay, this is not that useful for me. What I need is actually the step by step, right? How do I get there, right? So this is essentially the same thing, right? So this use case need to be fleshed out in step by step. That's why in your requirement document, you're turning in Thursday. Not only you have the use case diagram, but you also have the use case step by step. That's the minimum information you need to provide to your designer analysis. That could be you, or could be somebody else. However, at that time, one key difference at that time, you don't have the classes in the system identified. You are basically talking about the functionality of the system by standing right outside of the system, talking about the step-by-steps. Okay? In terms of, because you don't have those classes identified yet. Once you have the classes identified, now you can actually flash out. Basically what you do is you overlay your use case on top of your class diagram. Then you got your collaboration diagram. Basically this is the assignment of behavior to each class. Okay, this is a critical point in our lecture of this chapter. If you don't understand what is happening now, you better pay attention, because this is how you finish your design document. Exactly. This is not in your requirement document. Your requirement document pretty much will stop here.
So the scenario isn't part of the requirement document?
You can, that is something, you can have that in your requirement document, or you can have that in your beginning of your design document, up to you. Okay? So you could have that in your requirement document if you want to work more in this stage and give more detailed information about your requirement.
If we put it in our requirements document, does that mean we don't need it in the design document?
You don't need it in your design document.
Okay. And
In design document, what I'm looking for is what classes you identify, what are the attributes, what are the methods, and how they map using the collaboration diagram.
I'm confused now.
Okay.
So is the scenario thing needed anywhere?
Yes. Or so to be honest, I think it's better, let me say this, it's more, make your life better, easier, put that in the analysis document, will make it a little bit easier for you. Okay? Because that's where you really use that information to actually assign the method actions to your design. Okay? In here, so for instance, in this case, this is clearly in requirement document. Okay? You could run through the scenarios like this.